Alright, section 3.6, it's time to talk about money. So first things first, we need to know that an understanding of the proper use of money is important to living the godly life that's expected of us as Christians. We need to know how to spend our money, where to spend our money, just to be a good steward of what God has given to us. So here are some verses to go ahead and look up and see how the Bible talks about money. Then we have some definitions, and there are quite a few of them, so take your time pausing the video, writing them down to make sure that you are taking advantage of this opportunity and really getting to understand these parts of money. The cost is the amount a merchant pays for the merchandise he will sell. The merchant's just another person or another name for seller or the person who owns the business. So the cost is the amount the business owner pays for what he's going to sell. The markup is the amount the merchant or the business person adds to his cost to arrive at the retail price. The markup rate is the amount of markup on an item as a percent of its cost. Remember, when we see rate, it usually means percent. So the markup is equal to the markup rate times the cost, or the percent of the markup times the cost will give us the total markup amount. Then we take the original cost, we add on that markup amount, and we get the retail price. So those are really important formulas that you will need to have. The retail price is the business person's cost plus the markup, so what they've paid plus how much they've marked it up. It's the regular amount of money that a business owner asked his customer to pay for the merchandise. So the retail price is what we see on the tag when we go into the store. The discount rate, this is the opposite end of it. So before we were marking it up to make it cost more to get to that retail price that we're going to pay, now this is maybe things aren't selling so well, or they want to get more people in the store, so they're going to give a discount. So they're going to take a little bit off the top of that retail price. So a discount rate is the percent by which the retail price is reduced. And the discount is the amount by which the retail price is reduced. So we take that retail price, we multiply it by the discount rate, which is our percent, and that gives us the amount of money or the discount that we're going to take off of the retail price. The sale price is the customer's cost after the retail price has been discounted. So this is whenever they're having a sale at a store. They've taken off that discount and now they have a sale price. So we have discount is equal to the discount rate, or that percent, times the original retail price. And then we take that original retail price, we subtract the discount amount, and that gives us the sale price. So there's two different ways of doing these problems. One is what we just described. We take the markup rate times the cost and get the markup. So for the first one, Tom and Harry's Sporting Goods marks up all clothing 75%. If their cost for a shirt is $15, what retail price will Richard have to pay? So we just substitute in what they've told us. We know that the markup rate was 75%, so we'd write that as a decimal, 0.75. And we multiply that by $15, and we get the markup amount is $11.25. So then we take the cost of $15 plus the markup of $11.25, and we figure out that his customers are going to be paying $26.25 for this shirt, or whatever piece of clothing. Yeah, I guess it was a shirt. Or there's another way we could do this, that there's less steps involved. So when we talk about retail price, we know that it's going to be their cost plus an additional 75% of that cost. Well, anytime you're taking a cost, think of this as 100%. It's already all of it, and then we're adding on an additional 75%. So if we're taking 100, or as a decimal this would just be 1, and we're adding on the 75%, or as a decimal 0.75, we're saying it's the same as multiplying the cost times 1.75. And then we don't have to go through that extra step in the end of adding on when we did the markup plus the cost. Once we had figured out the markup, that gave us our retail price. But now we're saying, well, we can just get it all in one step by taking our percent and adding it a 1 in front of it for that 100%. And we've written it out here so you can see the steps, but you can really just do that in your head, so it's eliminating a lot of work for you. So we're just going to take that 175%, multiply it by 15, and we still get 26.25. So just in one step right here, we were able to find what the retail price is going to be. Example 2 deals with discounts then. So determine the retail price of a tennis racket if Paulo saved $52.50 by buying it during the 30% off sale. How much did he pay for the racket on sale? So we have to remember first of all that our discount equation is the discount rate times the retail price equals the discount. We know that the discount rate was 30%, so it was a 30% off sale, and he ended up paying he ended up saving $52.50, so his discount was $52.50. So we just need to figure out what R is. So this is just a one-step equation. We're just going to divide each side by 3, or 0.3 for 3% or 30%. And we get that the original retail price was $175. Then we can take our sale price equation. Sale price equals the retail price minus the discount, which was $175 minus the $52.50 he saved, and we find out that he paid $122.50. Or there's a second way we can do this one. So we know that the sale price equals the retail price minus the discount. We need to remember, well, what is our equation for discount? Discount equals the discount rate times the retail price. So when we see this word discount here, we can substitute in discount rate times retail price. So we can say that the sale price equals the retail price minus the discount rate times the retail price. So all we've done is taken what we know the discount is and substituted in the value for the discount, or the equation for the discount. So now we know the retail price minus the 30% rate times the retail price is going to be our sale price. Remember, sale price is still over here on the other side of our equal sign. And since we're saying retail price minus 30%, well, that's like saying, well, what's 100%, the retail price, minus 30%? It's 70%. This is the amount that I'm actually paying. So we can take 70% of the retail price, and we would get $122.50. So either way that makes more sense to you is perfectly acceptable. A couple more definitions. A tip is the amount paid for a personal service. So a lot of times we tip waiters and waitresses. So tip times rate, or tip rate, the tip rate, remember that's our percent, times the total bill equals our tip. Commission is the dollar amount an employee receives as a result of the sales he makes. For instance, car salesmen make commissions. So they might make a little bit of money, or maybe they don't make any, as like a flat hourly rate. Their big money comes from their commission. Whenever they actually sell something, they make a percentage of that sale. The rate is the percent used to determine a tip or commission based on the amount of the bill or an employee's sales. So remember, that's just what we talked about earlier, where rate is usually our percent. So commission rate times the sales equals commission. This is how much the employee is taking home as their commission. So example 3 dealt with another retail price. You can look through that. We're going to skip to example 4. Find Jeff's commission rate if his total sales of electronic equipment for the month were $8,250 and his gross income for the month was $3,660, including a monthly salary of $2,175. So here we have someone who automatically makes $2,175 a month, but then he makes more money depending on how much he sells. So first things first, let's remember, so we have his salary plus his commission rate times the sales equals his commission. So we have $2,175, which was his monthly salary. Then he has a commission rate that we're not sure of, but we know he sold $8,250 worth of merchandise, and his take-home at the end of the month was $3,660. So first things first is a two-step equation. We'll subtract $2,175 from each side. So now we know that $1,485 was the commission he made off of sales. And then we just divide by 8,250 on both sides. And we get 0.18. Remember, we were solving for a rate, which is a percent, so this would be 18%. And then the last concept we're going to look at is simple interest. So interest is the amount of money that you either earn off of money that you've invested, or it's money that you owe off of money that you've taken out on a loan. So I stands for interest in our equation. It is the amount of simple interest. P stands for the principal. That's the money that you either invested or the money that you're borrowing in your loan. R stands for your rate. It's the annual interest rate, so we'll put that in as a decimal. And T is time, and it's important to remember that in interest problems, the time in our formula always has to be entered in years. So if they give us months, we have to convert that into a decimal of years. It always has to be in years. So example 5 says Christopher invests the same amount of money in each of 2 accounts and receives a total of $36 interest at the end of 1 year. If the accounts earn 5% and 7% interest, how much was invested in each account? So what we want to do is to set up a chart to make sense out of what they've given us. So first of all, he invests money, but we don't know how much. We just know that in each account it was the same amount. So we're going to assign X for the first account and X for the second. Then we know that the first one earns 5% interest and the second earns 7%. So those are our rates, 5% and 7%. And we know that he is leaving the money in for 1 year. So our time is 1. And when we do these charts, once we've gotten this far, we just multiply straight across, because principal times the rate times the time equals the interest. So we take the principal that they gave us times the rate times the time, and it'll give us an expression for interest. So we'll have 0.5x and 0.7x. And we know that the total amount that he receives in the end is $36 of interest. So we're going to add these two numbers together and get our $36 of interest that he earned. And then we'll just solve to find out what x is. So we have 0.5x and 0.7x. Now we can eliminate our decimals like we learned about in the last chapter by multiplying each of these values by 100. So multiply this side by 100, and this side by 100. We end up with 5x plus 7x equals 3,600. Now, of course, you don't have to do this step. It just makes it a little bit cleaner whenever you're working your problem out. So we combine 5 and 7, and we get 12x equals 3,600. We divide by 12 and get x equals 300. So that means that $300 was invested in each account. And if we actually went back, which we always should, and plug in 300, multiply 300 by 5% for 1 year and 300 by 7% for 1 year, add those numbers up, we would get $36. Example 6, Robert borrowed $500 at a simple interest rate of 6%. 3 months later, he borrowed an additional $900 at 8%. If he paid off both loans at the same time and paid $33 in interest, how many months did he borrow each amount of money? So this time they tell us the principal amounts. So we have $500 at 6% and $900 at 8%. Now they've labeled our rows 6 and 8%. You could always just put the first loan and the second loan, whatever's easier for you to remember. Because we've labeled them 6 and 8%, it's really easy to remember for this one that our rate is going to be our 6%, or 0.06, and our rate for the second one is 8%, which is 0.08. Now, we don't know the times for these. We do know that we have to put in a variable for the first amount of time, which is x. Then for the second amount of time, it tells us that 3 months later he borrowed an additional amount. That means he's going to be paying back the first loan for X amount of months, but or X amount of years. So remember, our time is always years. But it says that the second one was taken out 3 months later, which means it's not going to be X, but it's going to be 3 months less than X. But we can't put it in as months because it has to be in years. So we know that 3 months out of 12 years is 0.25 of a year. So it's x minus 0.25. And then we just multiply straight across, because remember, our principal times our rate times our time equals our interest. So 500 times 6% times our x, and 900 times 8% times x minus 25. Sorry, x minus 0.25. Then we can go ahead and simplify what is 900 times 0.8 and what is 500 times 0.6. We get 30x and 72 times our x minus 0.25. It just reminds us one more time that x is in years, not in months. And when we go ahead and solve this all the way out, so remember, we're just going to take these two things. We're saying when we added them together, we know that it's going to equal $33. So we can build our equation just like that. We would have 30x plus our 72 times the quantity of x minus 0.25, and we'll get our 33. Distribute, we would get 30x plus 72x minus 18 equals 33. And then we can go ahead and combine our like terms. We get 102x minus 18 equals 33. Add 18 to both sides. We end up with 102 equals 51. And when we oops, sorry, I dropped my x. When we divide each side by 102, we get x equals 0.5. And so once again, remember, x has to be in years. So it's 0.5 years, or half a year, which equals 6 months. Okay? And again, that's it. That is in the example in the book, so it is spelled out for you. So the book has examples that deal with tip rates, commissions, markups, discounts, interest rates. So make sure you have a good understanding of all of them. I would really recommend practicing every time you work one out, write the formula across the top, just so it's getting ground into your brain. Don't get lazy and just take shortcuts, but really commit to this, because these are life skills. You're going to use these all the time. Maybe not commission quite so much, but still good to have that understanding. You're definitely going to use discount rates and sale prices and tip, all of those things, and even interest rate, because anytime you have a bank account or a savings account or you have to take out a loan, you're going to need to know these skills. So really commit to these. Let me know what kind of questions you have, and then get started on your assignment.